To demonstrate the shadow analysis macro, I've created a drawing with three simple models. The yellow rectangle on the roof plane of the model at the bottom of the screen represents solar panels, and I'm selecting that as the surface to analyse. Once selected, an arrow indicates which side of the polygon we're using. It's not always obvious which side the arrow is pointing to, so I can go to a different view to clarify, and if required, I can change the surface that's being used. Next, I'm going to select Casting Edge 1, and I'm choosing the model that's halfway down the screen. This represents an existing structure to be analysed. Lastly, I select the remaining model as Casting Edge 2. I'm selecting by group, but as the walls are in a different group to the roof, I need to use the Append option. This model represents a proposed new structure, the effects of which I wish to analyse. In order to do the calculations, the macro needs to know the north direction. I've already set it correctly in this drawing, so I'll leave that and go to specify the location detail. The country and city drop-down lists on the location form allow you to select any location that's already been set up, or I can use the options to add a new location or to edit the currently selected location. I'm going to add daylight savings information for this location before proceeding. I could specify a location file that will default into the next screen, but that is optional, so I'll leave that and go directly to Intake the Process. The process screen contains a number of options. I could select a date range or specific dates. For specific dates, I could automatically calculate the solstice equinox dates. The macro also calculates but doesn't select dates midway between those calculated dates. I'm going to use a date range for this example, and I'm just going to select a month around the middle of winter. At this stage, I'll just select a weekly frequency during that period. And I'll accept the Excel output file name that's shown, together with other defaults, before I press the Start button. The processing of the data for all the selected dates and times may take a little while, but it's important to remember that this is now running as a separate process, and you could return to DataCAD to continue working if you wanted. As I've specified an Excel output, it will open an Excel window and generate the output directly into that. As you can see on the screen, the resulting columns C and D show the shading caused by each set of entities. Column E shows the total, which, because the two shadows overlap, is not simply the sum of the two individual numbers. Column F shows the increased shading caused by the second group of entities, which represent the proposed new structure in our example. From the data displayed here, I can see that significant shading occurs around 3 p.m. each day, so it may be appropriate to do a more detailed analysis of that time slot. I'm going to run the report again, this time for a time period between 2 p.m. and 5 p.m. and I'm going to use a time interval of 15 minutes, so we'll see finer detail, and I'll run it for every other day instead of weekly. I'm leaving all the other parameters the same, and I'll click the Start button. Because the output file already exists, I'm prompted to either replace it or to add it to the existing file. I'm choosing to add it to a new sheet, which I'm going to call Afternoon Analysis. That sheet is automatically added to the output Excel file and data written to it as the calculations progress. I'm running on a fairly slow laptop, but even on a fast machine this can be time consuming, so it's important to remember that you can leave it to run in the background and swap to DataCAD or any other program to continue working whilst the calculations proceed. If you return to the Shadow Analysis program window, you can see the date that is currently being calculated in the status window. The resulting sheet has the same layout as previously, but with the data showing the new date and time increments. You can examine the data or analyse it using Excel's formulas and tools. It's no surprise to find that the maximum shading occurs around about the 21st of June. I expect that shading in this scenario is not going to be a problem during summer, but you could run other analyses to find, for instance, the date in the year when shading will first become an issue and the date when it will cease to be an issue. Thanks for watching this demo.